we were deficient of the total permissible deformation. The structure's deformation under wind load was not under control. And then we utilize a structural system that is called as Outtrigger. So there are 1, 2, and 3 Outtriggers are provided at these 3 levels. And because of this, I will explain how we reduce the deflection. So in the next slide, I will explain that. So you can see here. So this way the moments are developed under the wind load. This is the wind load. This is a shear wall without outrigger. And these are the moments developed. With this introduction of outriggers, you can see here, these moments are reduced here. And the deformations are also then came within control. And not only the deformations are important, comfort level accelerations under wind loading is also important. I mean, whatever the accelerations are developed under extreme wind conditions, they should not disturb the residents. They should be within the limit of perception, and the comfort criteria should not be disturbed there. Of course, as the height goes on increasing, seismic, as compared to seismic, wind forces becomes more critical. And again, the evaluation of wind forces need to be very precise. And for such buildings, we recommend to perform the wind tunnel test. So this is the wind tunnel test. The setup is there. Actually, wind flows in different time of year in different directions. So this all load evaluated for 36 cases. Each 10-degree load, what is the load coming for that particular wind flowing in that direction. So this way all 360 degrees are covered, and 36 basic wind load cases are evaluated, and then they are applied to the structure. So now these are the permissible deflections, H by 500. These are 512 millimeter, and with the proper outrigger arrangement and all this, we have achieved it at 360 millimeters and 360 millimeters in X direction and Y direction, which is quite a fair number. This is about wind-induced acceleration comfort criteria. So for this residential also it is up to mark, it is not exceeding the mark. What happened under the winds, extreme winds, structure starts oscillating and accelerations are induced in the structure. They are not, from safety point of view, they are not critical, but from comfort point of view, they are critical. So different agencies, ISO, RWDI, they give particular number, value of the acceptable acceleration level. And then that acceleration level is achieved here. So for a 10-year return period, the peak acceleration is 16 milli-G. So 16 milli-G is what is felt as comfortable. One don't feel it as a disturbed one.